So today we are going to do a graph project. Mm, I'm going to use JavaScript to plot some graph here. Mm, Basically, we are going to plot graphs for one binary search algorithm and one linear search algorithm. Basically, so we are going to plot um, how graph behaviors as array size increases. So let's see. I'm going to use white for scaffolding my JavaScript project, and I'm going to use JavaScript. No, TypeScript. I'm going to use TypeScript. So let's get inside there. I'm going to create to create a white project. I'm going to use latest white package. Okay, lab one. This was my lab one project from my university. Algorithm subject was algorithm complexity and algorithm complexity. So vanilla. I'm going to use TypeScript. Cd into lab one. Installing all the packages. Okay, so these are my this is my JavaScript project. So let's open it in VS Code. Install I will install it. So npm run dev. So it is going to look that like okay. Let's create our binary search. Yes. So I'm going to write binary search algorithm here. Binary search algorithm takes an array, which is going to be array of number, and a target to be source, which is going to be number. Okay, and left value is what is the left value? Initially it will going to be 0 for initial array, and right, and it is going to return, this function is going to return number as well. Let's create a prettier file so that we can read it. So .prc file. So we don't have to write for auto formatting false as tab it for print. Okay, print with 100 no semicolon false. So okay, this is the first of all, first case is if left is greater than right. Obviously we are going to return -1 here, and if we are going to calculate mid values, we are going to use float to convert decimal values to whole number. Alright, plus left, okay, divide by 2, and if we find value at the middle, and this is our best case scenario, we are going to return mid index, that index which is going to be mid. So if all the initial cases are not fulfilled, then we are going to simply look it again. We are going to use recursion here. So if array of mid, if our current value is greater than target, there's something here is we are going to do something. So 1 2 3 4, if this is our, let's say our this is our array, so our target is our target is 2, let's say, and our mid value is here. Then what is we are going to do? We are going to shift here. So binary sort target is target. Okay, target is here, but our mid value is running here. Okay, no, our mid value is here, but target is here. Then we are going to minus and opposite case for our We can also generate some documentation for it. Okay, simply this is going to be array of number, obviously. Let's copy paste it here. Or are going to be same as well. Okay, we are pasting it here, and it is also going to return a number for us. Okay, this is our binary cells. This is all just simple documentation. Okay, let's do some testing as well here. Okay, for testing we are going to use just we are going to install it at dependency, dev dependencies, and we as we are using TypeScript, so we are going to also install ties for this. Okay, just create file while it is installing it, binary source dot test.ts. Okay, it is installing. No problem. Okay, let's import our binary source. Okay, it's not really binary. Spotify binary source. Okay, installing. Okay, binary source takes an array, const array, our array will be our target is 3 and left is 0 and right is -1. 2b is going to be 2. So in order to run our test, we need just configuration file. To do this, we have to run this command. This will simply create just config. Also we need just ts just. So what this does is it simply finds out all the TypeScript file and it will parse them to JavaScript and test it. We don't have to parse, we don't have to compile them to JavaScript, so it will do all the things for us. Okay, let's create a command for doing that, for testing our TypeScript file. Test. So let's see test. Okay, it is passing. Okay, also write something else. Yes. I'm not going to create documentation for this. Proteus. For this we are going to copy that again. This is linear source. This is linear source. It will not going to take left, right, stop. Okay, let's run now test. Okay, everything is working fine. Now let's start with our plot. For plotting, I'm going to use plotly from JavaScript. I'm going to use minified version for it. So this is I'm installing the plotly library. It is installed. As we are using TypeScript, so we are going to install types as well as a tip dependency for sure. Okay, it is installed. Just as it is. Okay, in our main, I'm going to trigger all the things. In our this is going to be one. Okay, I'm going to create some placeholders where I'm going to plot graph. This is going to be for linear. This is going to be binary. Okay. Okay, let's leave it for in our main graph. Let's create a function to generate a graph. Generate for linear. Okay, let's create a variable to store all the results from our iteration. Okay, now best case, we are going to create 3 cases. That is going to be best case, worst case, and our average case. Each cases will have their respective array size and times they took. I'm going to copy it. Okay. Average case, worst case. Okay. Okay, I'm going to create interface for the result. Best case. This is going to have sizes. Times. Okay, yes. And for all the results, interface install state. Okay, I'm going to copy a state here so that I don't have to repeat it again and again. This case, worst case, this is the result here. So let's first create our array of size 1 billion. Array from is going to generate array, and I'm going to need I'll give 1 million to array constructor for creating 1 millionth size length of array. 1 2 3. We are going to use keys so that I can generate from 0 to 1 million, like 0 1 2 up to 1 million. 1 2 3. Now I'm going to generate. So now our next target is going to be generate our data set, which is going to include different array sizes in increasing order. Let me show you. Okay, this first data. Obviously it is going to be array of array, because we are going to have different array sizes there. Array of numbers, array of array. Initially is going to be empty. So let's iterate through each array. Okay, using good old for loop. I less than dot length. I is going to be I plus 1000. We are going to take different array sizes in increasing 1000 order. Okay, so how are you going to do this? Okay, dot push, we are going to push array, and slicing is array. Slice is going to be gives us new array from 0 to I. So what is happening here? From 0, first of all we are going to store 1000 array size, second 2000, third 3000. This way we are getting different array sizes in increasing order, so that we can test our algorithm in decreasing array sizes. Okay, now for best case, we are going to test best case for each array. For each, I'm using for each to iterate over. For each is built in a JavaScript method to iterate over array. So let's do it. For best case, what is going to be best case? Best case for linear sorting is simply the first number. Best case option is going to be 0. Obviously. So in JavaScript, we can use performance.now to get our performance before and after operation. So our operation is going to be linear search and array, current array, and best case option. And after, what is going to be performance after that operation? T2. We are going to take the difference between T2 and T1 to get the performance of linear search. So as we created this, we have already created the best case data results. So we are going to store that result in our result variable. Okay, result. Okay, dot test is going to be suggest me, auto suggest me all the values. Dot push size is going to be error dot length, and our time is going to be T2 minus T1. Okay, I'm going to repeat this process for all other cases. Best, average, and worst. Average case. Okay, what is going to be the average case? Average case is going to be simply random value. Using random value, I'm going to use pseudo random method. Okay, floor. I'm going to use floor to get floor values, so that I don't get decimal values, to get index values. Okay, math.random is pseudo random way of getting random values. I'm going to use trigger to get random values within that array length. Okay, average case is there, and I'm going to insert into average case. And worst case, what is going to be the worst case of linear search? It is going to be the last item. Yes, worst case, I'm going to push it inside worst case. Okay, so we have created all those result inside the result. Okay, let's, now what are we going to do? We are going to create a plotting the data. Best case plot data. Let's name it that way. X going to be, what is going to be the X? Result dot best case dot X is going to be our sizes, and Y is going to be our times. Let's give it a name. Best case and line. We are going to give color to that line. Mode is going to be line. Simply I am remembering all this from Plotly documentation. All of these are in Plotly documentation. You can visit there. RGB value is going to be, let's give it simple, and this will be fine, I think. Okay, it is missing here. I'm going to repeat same case for best, average, and worst. So average case, case log. Okay, average case. I will change color. Okay, I'm changing color. So now I'm going to plot this in our placeholder here. So to do that, I'm going to use new plot from plotly and give it all the data. This plus plot data is equals to first of all look equals to best average worst. I give all the plot data. I think this is it. Okay, it is. Data was not found. Okay. First it will take our placeholder id value. What is the id value? Linear. Okay, let's see what happens. Okay, I'm not calling the function generate for linear. Okay, it is doing its magic. Okay, we can see that average case is running between worst case and best case. Yes, I think that is the pattern. Okay, it is working fine. Yes. So now let's do the same process for our binary search. See what is going to be. I'm going to simply copy all this because everything is same as previous one. Change the name only. Change for generate for binary and linear search is going to be changed to binary search, and it will take our initial error total length -1. Okay, binary search is going to take this. Okay, 0. What is going to be the best case for binary search? It is going to be middle floor value. Okay, dot floor error total length -1 divided by 2. Best case is going to be, and what is going to be average? Average is going to be random value. And what is the worst case? Worst case is if it does not find any values. Okay, this is going to be worst case, average case. Okay, I'm going to give it okay, this is generated for binary. Also process also be changed to binary because I created a new binary placeholder also. I'm going to just call generate for binary as well. Let's see the magic. Okay, it is processing. Okay, you can see different thing. I know why is this happening, because our t-1 is very small, so it is not going to, we are not going to see some differences here. So to see some plottable data here, I'm going to simply map this to some different values, some plottable difference here. I got this from Eaton Dalmeter previously. Let's see. Okay, we can see that as expected. This is also looking logarithmic. Okay, average case is between worst case and best case. So this is the way I did my JavaScript lab first project in JavaScript. I'm going to create a GitHub repository of this project and put it on the description of this video. Thank you.